Okay, Assalamualaikum. We'll continue with another topic, which is a bandstop filter. A bandstop filter rejects frequency between two critical frequency. You have the first critical frequency and another critical frequency. It will pass the frequency over here, but not in between. Okay, you have a center frequency over here. The bandwidth is still cut off over here minus the cut off over here, and this is the passive bandstop filter, LC parallel, and you have R over here. This is opposite of a band pass filter. If you remember, for the band pass filter, your R is right here, LC is placed over here. Okay, so bandstop sometimes is called a notch filter, a band reject or band elimination, because it eliminate or reject this particular frequency in between the pass band over here, another pass band over here. Okay, and if you look closely, this is opposite of the response of a band pass filter. For a band pass filter, you have the frequency in between, but at the low and high frequency you don't have any frequency. The bandstop filter can be constructed using a low pass and high pass filter, but this particular low pass and high pass filter is summed up together. Unlike the band pass filter, for the band pass filter we have a low pass filter followed by another high pass filter, or the other way around. High pass filter, the output of the high pass is the input to the low pass filter, but this time the low pass and high pass is summed together to get this. So this is for the low pass and this is the high pass. You sum that, you have a frequency over here, a frequency over here, but not in between. So this is the circuit, the first circuit. This is an integrator, the C over here. So this is a low pass filter, and this is the high cutoff filter, which is the differentiator. So you sum the output over here going to this, another output of the high pass filter going into the summing amplifier, and you'll get the output, which is a bandstop filter. Okay, another circuit. Okay, this is circuit 2. This time we are using the ordinary first order. This is a couple of RC over here. The position C and R is different from the bottom part. So one is a high pass filter and the other one is a low pass filter, and we sum up together using the summing amplifier and negative summing amplifier. For this particular circuit, the gain will be minus 10 over 10 of this output, minus 10 over 10 of this particular output. So the result will be, this is the pass band, which is for the low pass filter, and this is the pass band for the high pass filter. It will reject the band in between. Okay, the maximum gain will be 2 right here. Okay, the gain that I have mentioned just now, and the center frequency over here, which is the multiplication of high cutoff and low cutoff, and you find the square root of that. Okay, how to get the high cutoff and the low cutoff? It is simply the value is 1 over 2 pi RC of this and 1 over 2 pi RC of this. Okay, another bandstop filter is using a multiple feedback. Again, multiple feedback because we have one and another one over here, two feedback from the output to the negative inverting terminal right here. So that's why it is called a multiple feedback. And if you remember, the input right here, V in, is going to both. It is something similar to the all pass filter. Okay, so we have several resistor R1, R2, R3, R4, and 2 capacitors C1, C2. Okay, so you can have, or you can find the transfer function that describe the behavior of the circuit. So find V out over V in. Similarly, just use the current convention. R1 equals to C2 IC1. Right here, IC2 equals to IR2, IR3 equals to IR4. Okay, I left that as an exercise for you. And we have a state variable bandstop filter. If you remember, a state variable in the bandpass filter. So right here, the state variable filter has a low pass and high pass output. So we combine those low pass and high pass into, we connect it into a summing amplifier. Okay, so with this you have a bandstop at the output. Okay, remember that the state variable filter, it is a 3-in-1. You can have a band pass, low pass, and high pass. So we use the low pass and high pass output combined together through the summing amplifier. Okay, so this is the circuit. Okay, this is the summing amplifier. The state variable is all this: integrator, summing amplifier. So you have a high pass output over here and a low pass output over here. So we're taking the low pass output, we're taking the high pass output, sum it together, you have a bandstop filter. Of course, the state variable has a bandpass filter over here. Okay. The center of frequency of the state variable is given by this 1 over 2 pi R4 C1, and it is similar to 1 over 2 pi R7 C2, and the quality factor is 1/3 of R5 over R6 plus 1. Okay, and this is the example of a state variable bandstop filter with the value of R4 and R7. You have to find that the value, but the given value is the capacitor C1 and C2, and it is 0.22 microfarad. And if you calculate, the frequency is given at 50 Hertz. You'll have a 14.47 kilo ohm, and there is no available 14.47 kilo ohm resistor, so we can use the nearest 15 kilo ohm resistor. Okay, so with that, I conclude about the bandstop filter, and thank you for watching this video.